Hi everyone, I'm gonna present the model I built for the SIGTYP 2021 share task. This year's task was a multi-class classification task for prediction of 18 language IDs from speech recordings. The dataset which was provided consists of 80,000 NumPy files containing Mel-frequency cepstral coefficients. What is important to underline is that the training set instances are very different from the validation set instances. The training set contains readings from the New Testament, while the validation set is made of instances from very different sources. The major challenge of the share task is to build a model being able to generalize to recordings of different content, genres, and of course different speakers. Each instance is a two-dimensional tensor with the first dimension being 39 and the second varying between 301 and 501. As you can see from this table, the 18 languages involved belong to different families, 8 to be more precise, as the different colors show. I started with building a recurrent neural network model, since each instance is a two-dimensional tensor and therefore can be conceived of as sequence data. I built a model with 3 recurrent neural network layers and 2 dense layers, with the last one outputting the probabilities for each language. The plot on the left shows that this model quickly overfits. It's not able at all to fit the validation data. I also tried to train a new model with the same architecture after adding 60% of the validation data to the training set using stratified sampling. But also in this case, the results shown in the plot on the right are not very different from those shown in the plot on the left. For this reason, I tried to train a new model, a convolutional neural network, after transforming the Mel-frequency cepstral coefficients into spectrograms. The idea is that convolutional neural networks should be more powerful in identifying patterns, and indeed the model is able to fit the training data very quickly, as this plot shows. Unfortunately, though, this is another case of overfitting, in that the accuracy line for the validation data essentially remains flat. At this point, I try to fit the data with a more powerful convolutional neural network architecture that is the ResNet-50 where, as is known, 50 refers to the number of convolutional neural network and dense layers. ResNet is not only a very deep architecture, but it's also known to work very well because it employs the mechanism of residual learning to overcome the degradation problem. The accuracy results are, I'd say, pretty good, as this plot shows. More precisely, the training accuracy is 98, the validation accuracy 73, and the test accuracy 53. This last score seems to suggest that the model partly overfitted the training data. The confusion matrix for the validation data shows that the class error rate is rather high for English and very high for Sundanese. On the contrary, the model performs very well for Basque and Telugu. These results are in line with those for test sets. Additionally, however, Indonesian and Russian are often misclassified. What can we conclude? A capable enough model such as ResNet-50 can fit the data successfully, that is, without overfitting. Sundanese is erroneously tagged as Javanese in both the development and the test sets. I don't really know why, because I don't know these languages, but this might suggest that there is some structural similarities between the languages. English is also often misclassified in both the development and the test sets, although differently. And finally, in the test set, class error rates for Russian and Indonesian are particularly high. This might be due to the fact that the test set contains recordings with different genres, content, and speakers. Thanks for your attention.